Okay, I've kind of organized a little bit on the board. Let me introduce you to what I have on the board. I don't have everything in the board, but I want to do it together, okay? This is the ski, this is the hill here, correct? This is 12 degrees here. 60 kilogram skier being pulled up the mountain, correct? Yes? Here's the FW, FP, and FF. Yes? So far so good?
Yes.
Okay. This is what's given, 100 meters. That's given as, that's actually DI. Important to make that connection, DI, right? Yeah. 60 kilograms, 0.12 is the coefficient of kinetic friction. 12 degrees, 200 newtons is the applied force. I want to do all of this. I want to do DO, FO, FW, FI, FI ideal, FN, FP, FF, WI, W down. I'll explain to you what that means in a second. WF, WI, delta KE, delta PE, A at VF, etc. Okay? We've done some of the things already, so let's put that in. What did we do already? What do we know? We did this, right?
Yes, we have FN, which is 586 newtons.
All right. 500.
FP, which is 125 newtons.
Okay.
FF, which is negative 70 newtons.
Right. Let's not say negative yet,
Okay.
just because I want to build that. What else?
And
Is that it? Is that all we did? Oh, FW is here, right?
yes, FW is 600 newtons.
All right, that's what we did so far, right?
Yes.
So also, very important, I want to draw in this is going to be FF, which is negative. That's FP, which is also negative. This is FA, which is positive, right? Correct? Yes?
Yes.
So we can say that this is positive here. You all right with that?
Yes.
This is negative. It's negative. Okay, so far so good? Is everybody comfortable with that so far?
Yes.
Okay? Excellent. Now, what else can we do here? What else can we do here? Anything?
We can find
What's FI?
200 newtons.
200 newtons. Let's do a color coordination scheme here. I don't have a lot to choose from. Let's see if this works. So what's this, 200 newtons?
Yes.
So it's plus 200 newtons. Oh, that's nice, huh? Nice and dark brown. Yeah, I like that. All right, what else? What's what's FO? F output. What is that? 600 newtons. Very good.
How is that found in this equation?
FO is always the FW. FO is FW. FA is FI. Okay?
I see.
All right? All right. What else can we do? This is DO, right?
Yes, that is D.
Okay. How would you find DO?
Well, we have DI, which is 100 newtons.
DI is 100.
100 meters.
100 meters.
Right?
Right.
So we can put FI, DI, I mean,
No.
No, wait.
Okay.
FO,
DO.
DO.
No, no.
No, I'm wrong. Never mind.
That's okay. You take your time.
That's
Use
fine.
trig. Isn't this 12 degrees?
Okay, yeah.
Isn't that opposite?
Yes, it is.
Isn't that hypotenuse? So isn't it going to be, think back,
Okay, I see.
is it going to be opposite equals hypotenuse times sine, right? Times sine 12. Can I write right here? Can I erase this for now?
Yes.
I'll come back. I'll put that back in, but I need you right there. Just remind me that this has to go back in, okay?
Okay.
I'll erase that for now. That'll be like my little workspace, okay?
Okay.
All right, so do you understand that sine theta equals opposite over hypotenuse, right? I know 100 and I know 12 degrees. So sine 12 degrees times 100 is what? What's sine 12 degrees times 100?
21.
What is it?
21 meters.
21 meters. Excellent. 21 meters. Okay? 21 meters. So I can put down here 21 meters. So this is 21 meters. That's DO. Right?
Yes.
Okay? Good so far? Yeah? What else can we do? Anything else?
We can.
Can we do the ideal yet? Can we do the ideal yet?
Yes, now we can.
Okay, how do I do the ideal?
Okay. FO.
All right. What is the, are you ready for this? Are you ready? You listen carefully. You ready? You ready? You ready? Ideal machine equation. What is the ideal machine equation? Anybody?
FO times DO divided by.
No. FODO. No. Yeah, FODO equals FIDI, right?
Yeah.
Okay? So FODO, we have a visitor. Dr. G is here. Yeah! We simply call him the Hobbit. You know, we're very nice to him. We call him the Hobbit. His feet are very Hobbit-like. He wears no shoes. And he has these giant Hobbit feet. Very hairy. Now, Dr. G, how often do you shave your feet? Like once a week or?
Twice a day.
No, twice a day. Excellent. Now, you don't wax your feet? Is that like a Hobbit thing? No, they don't wax their feet?
That is correct.
Yeah, see, that Hobbits don't wax their feet. They shave twice a day. You've heard it here first. Excellent. All right, now, so that's FIDI. Yeah? So, Shema divided by Shema. So FODO, what's FO?
FO is 600 newtons.
What's DO?
21.
21 equals FI, which we don't know, times what?
Times.
100. I'm leaving off the unit labels. I always ask permission to do that. Is that okay?
Yes.
600 newtons times 21 meters, right? Equals FI times 100 meters, okay? Is that confusing you? Is that okay to do that?
Yeah.
Okay, do I have your permission?
Yeah.
Excellent. There he goes. God bless all hobbits living amongst us. Okay, now, so FI equals what? What is 21 times 600 divided by 100?
126.
Excellent. Gosh. Okay. Excellent. So where does that go?
Under FI.
FI ideal.
Where?
Above FN.
Okay. Okay. What is it?
126.
Okay, good. So you with me?
Yeah.
You with me? Yeah? Okay. Excellent. Now, what else can we do?
WF.
WF. Excellent. What's WF?
WI.
Would WF, wouldn't WF be the friction times the...
Friction time. So what I do is I put the WI ideal.
Well, what's work? What's work?
Work?
Isn't it force times distance?
Yes.
Okay, so wouldn't WF somehow involve the force of friction?
Yes, it would.
And what length, what distance was that friction applied over?
100 meters.
Ha! 100 meters, right there. Excellent. So what would, you ready? You ready? You ready? You ready? You ready? 70 newtons times 100 meters equals
7,000.
7,000 miles per hour, grams, newtons. You always get hung up on unit labels. Joules. Why are you shy and bashful? Shout it. Take ownership over it. Joules. Yes, excellent. So joules. So 7,000. Where's that? Here.
Yeah.
7,000 joules. Okay. We're getting there. Yeah. We're getting there. Yeah. Okay. What's WI? What's WI? Now, unless it's otherwise stated, it's always the real one, right? WI is always the real one, unless otherwise stated, right? So what's WI?
20,000 joules.
20,000 joules.
TI times FI.
I am in the presence of greatness. That's absolutely correct. Why? Because 200 FA, right, times 100 meters, right, which is DI, FI is FA, 20,000. So that's 20,000 joules. Okay? Yes? You with me?
Yes.
You sure? Okay, good. Now what is W down, the work down? Careful. What's the work down? What's the force that makes that skier want to go down the hill? What is that force? What's the force that makes...
Gravity.
No, what part of gravity? In other words, is it FW? What part of gravity, what part of the weight makes it want to roll down that hill? I'll give you a hint.
FP.
Yeah, FP, right, exactly. Isn't it? Isn't FP that force that, isn't it that, hold it, I got it. The part of the weight that is parallel with the plane is called FP. FP times 100 meters would be W down, right? We could call it W sub P. The book calls it W down, WP, either one. But what is it? 125 times 100.
12,500.
12,500. So 12,500 joules. Good. What's the ideal work? What's the ideal work? What's the ideal work?
13,000.
What is it?
13,000 joules.
Well, how do I get that?
WI real minus WF.
No. No. How would you get the WI real? How would you get that?
Oh, okay.
WI, doesn't WI equal FIDI? Does DI change? Is DI always DI? Yeah. But what would you use? Would you use FI real or FI ideal or?
Ideal.
Yeah, so what's FI ideal?
That's 13,000 newtons, right?
126 newtons, right?
Okay.
Right?
Yeah.
Right? You
Yeah.
get it?
Yeah.
So what's FI times DI real? FI real times DI. What's that gonna equal? No?
12,600.
Yes. 12,600 joules. Okay, we're almost there. We're almost there. We haven't put it together yet. I'm not asking you to understand it yet. I don't want you to understand the big picture. If I ask you, do you understand the big picture? You know what you're supposed to say to me?
No.
Absolutely not. Right? Right? Right?
Yes.
This is what I want you to say yes to. Do you understand, apart from the big picture, how I calculated each one of these purple and brown values? Do you understand it?
Yes.
Yes.
Yeah.
Can you-
Solely, specifically by themselves. Do you understand that? Yes or no? Blah.
No, just for two.
Blah.
Can,
No. Yes.
can you just tell me what you did for WF and W down once more?
WF was the friction.
Was
the force of friction
Okay.
times the DI. Doesn't that make sense?
Yes.
Okay, well, the force of friction was 70 newtons,
Work on friction.
and it's being applied over 100 meters.
Okay. It's
So
the-
WF would be the frictional force times what?
the distance.
Times
it's measuring
DI,
the
right?
distance, yes.
Right?
Mhm.
Yeah, okay.
And then W down.
W down,
U.
okay, would be W down, would be FP times DI.
FP. Okay.
Okay?
I see.
Yes?
FP. Okay.
Easy?
The power.
Okay, all right, okay, all right, now. So far, so good. Now, let's quit. Let's do a third part. You know why? Because this is gonna stop. And I wanna, this is a good stopping point, okay? Because I wanna download this and then come back and we'll finish it up, okay? So, this is where I want you to be. I'm not gonna erase any of this. Do you understand how I got all of this?
No, I do.
Excellent. All right. L, would you like to do the favors, do the honors?
Yes.
Okay. Have a good day.